Okay, this is where we have left off. So this is the final part of the chapter one, the topic one, which is our lighting. So we have left off from the only remaining thing we would like to talk about is natural light sources, which is from the sun. So previously we have learned what is lighting. So hopefully you guys still remember. And then we learn about how to do basic calculation. So what is the difference component in lighting? So in lighting, one of the summary, the most important summary is this summary, which is the lighting measurement. So from here, you know that your light source is represented by the luminous intensity, and then you have your flow of light energy, which is represented by luminous flux, and then you have finally your illuminance on the surface, which is represented by the lux, the illuminance. So this is very summarized. Yeah. Okay. Sorry, I forgot to share the screen. Yeah. So okay. So I'm just mentioning about this. Just a quick recap on your topic one. Okay. So this is the last remaining part regarding your topic one. Okay, so when we talk about natural lighting, which is from the sun, when it comes to building, we have we can use either the light source from our sun, which is only reliable during the day, or we have to supplement it with artificial lighting, which is what you have learned previously on the previous lesson. So a room can use natural light, artificial light, or both natural and artificial. So for a normal building, meaning for a building where it is for us normal resident to stay in, which is residential building, not for commercial business, not for doing businesses. So we will always want to use more natural lighting. So that's why you see in your house there's actually a lot of window or sliding door. So this is to allow more natural lighting to come in, and this is also actually a requirement when we design a building. So basically, when architect design a building, they actually has a requirement to fulfill, meaning they will need to have a certain percentage of natural lighting going into the house. And in the case of commercial, because the building is very very big, so natural sunlight cannot reach all the way into the building. So that's why we have to supplement it with artificial lighting. So in a case where you have a very, very big building and natural sunlight will not be able to shine all the way into every corner of the room. So that's why when comparing it to normal residential building and commercial building, there's a difference between their design. So when it comes to a normal residential building, then if you are interested, you can go and study more on the design requirement. So this one is more towards the architect requirement. If you're interested, you can go and find it out Okay, so natural light, which is from the sun, can go into our building through means of window and skylight. So skylight meaning we have a window on top of our ceiling. So in the case of Malaysia, we don't really have a lot of skylight So depending on where our room is in, the quantity of natural light is governed by the nature brightness of the sky. So how big and where's the position of your window? Is there any reflection in the room? And any reflection and obstruction from object outside the room. So sunlight can come into a room in different way. So it can be direct, it can be indirect, or through reflection. So previously we learned that depending on the surface, there's a level of reflectance, meaning a white surface will have better reflectance as opposed to a black surface. So a black surface will absorb the sunlight, while a white surface will actually reflect more light than a black surface. So all of this will come into play lah when it comes to how bright a room is like. So there's okay. So next we have your direct sunlight. So when it comes to calculation and when it comes to modeling, we know that sun. If you look at the sun directly, is actually very bright, and it can actually cause your eye to go blind. So therefore, we do not look at it directly. So we can, if you were to measure how bright the sun is, then we can get up to 100,000 lux. So we do not want direct sunlight because it is too bright. So we call this sort of light glare because it is so bright. So when we look at it directly, it's actually a very blinding light. So in a normal working building, meaning if you go for commercial purposes or even residential purposes, in a normal building, we do not want direct sunlight. So that's where we install all these uh, additional building services. So we can have an external control, we can have an internal control, or we can have any special glasses. So external control can come from awning or window screen. Internal control can come from blinds or curtain. So this one is the awning, meaning there's building, additional building or installation attached to the outside of the building, so that the direct lighting doesn't go into the building, doesn't go into the room. So it will not be so glaring lah when you look at it outside. So finally, we have your special glass. We have tinting or low E glass. So all of these additional additional protection will not allow direct sunlight into the room. So this is due to the sun having a very high level of illuminance. So if you look back at the table, let's see. Yeah. So if you look back at the table, when it comes to the standard service of illuminance, actually we don't really need such a high level. So the level of lux required for a surface is just in a range of 100 to at most 1,000 when it comes to fine work or electronic assembly here. But when we measured the level of illuminance or lux from the sun, we found that it's able to provide a very high level of brightness. So maybe one day when you are reading a book outside using sun, you'll notice an example where the book, because of its white surface, is very glaring. So maybe one day when you're outside, you'll be able to encounter this sort of situation lah. So this is due to the sun being very bright and making you unable to read a book outside. So this is just one of the example lah. Or maybe you have a phone, you're trying to look at your phone and you're outside and the sun is glaring at you. So you'll notice that you will not be able to see your phone because it is so bright that it's is blinding the information that you want to read. So this is a difference between our natural lighting available, which is from the sun, and our artificial lighting. So our artificial lighting, we can control it. We can buy the artificial lighting, which is not so bright or which have some sort of spec behind it. But natural lighting from the sun, although it is free, is actually very, very bright, and we have not much ways to control it except for these few methods, which is to prevent unwanted glare from the direct sunlight due to the high brightness. But then again, it's free lah, so you always try to want to use it. So depending on where we are, there will be a different variance behind the brightness of the light from the sun. So it can be due to the time of the day, season of the year, or local weather. So when it comes to calculation, we have two types of model, which is the Uniform Standard Sky or the CIE Standard Sky. So when we talk about standard sky, meaning it's just a constant, just a normal sky. We set a value towards it. And when it's a overcast sky, meaning our outline of the sun cannot be seen through the cloud. So these are just two type of mathematical model when it comes to our sun. Just an idea behind it so that you guys know about it. Okay. So when it comes to a normal uniform standard sky, we give it a constant 5,000 lux for a standard daylight calculation. So this is an unobstructed view from the sun to the sky to the ground. And that is what is called a uniform standard sky. Okay, so next we have a daylight factor. So this is actually derived from the sun, the amount of daylight required in a room by measuring it, comparing it to the total daylight available outside the room. So this is just basically a ratio So we have a formula here. We have a daylight factor, and then we have the illuminance outside, inside the room, and then illuminance outside the room, multiplied by a percentage. So we are always given a 5,000 lux for the outside. So unless stated otherwise, you will use 5,000 but usually the question will give it to you. Okay, so we have example 7, which is a daylight factor. So given that you have a 4% minimum daylight factor required inside this room, so we need to calculate what is the natural illuminance that this represents, assuming that an unobstructed standard sky gives an illuminance of 5,000 lux. So pretty straightforward. You'll be given the daylight factor percentage, and then your EO is given. So you just plug in into the formula. You'll get that the natural illuminance is 200 lux. Okay, so since we have a table for artificial lighting, we actually also have a standard table for daylight level. So how much daylight we require for a room. So this table shows a recommendation of daylight factor for various locations. So depending on the type of activity required, then we have a different minimum daylight factor. So this, if you plug it back into this formula, it will represent a value of lux. which the room requires. So this value here is what's being played around lah. What's the daylight, minimum daylight factor required? And when we use this formula, plug it back in, it will give us a level of lux required, which will be very close to what is given here. Okay, so when it comes to natural lighting inside a room, there's actually three components. So the most direct, the most main principle is the sky component, and then you have any externally reflected component, and then we have any internally reflected component. So a direct component will be the sky component, which means the sun directly shining into the room. So we will actually have a surface reference. Let's say in a room, we have this room is used for studying. So where's the surface reference? It will be on the table. So any sky component which is direct from the window will be shining here. That will be called a direct sunlight. And then we have two other minor component, which is reflection, which is based on reflection. So we have externally reflected component, which can be shining from another building or a wall where they are reflected outside the building, going to the reference point. And then we have another, which is the internally reflected component, meaning we have the light from the sun, but it's reflected inside the room. So all of these, when they are combined together, they will add up and become the level of brightness in the room. So reflections into the room can come from two sources, meaning from outside, and then another one from inside. So depending on how we made up our room, meaning the colors and the object in the room, it can either increase the brightness or decrease the brightness of the room. Same goes for what is outside lah. So outside, if you have a building with mirrors, then there will be more externally reflected component as opposed to having a black wall lah. So if you have a black wall, then there will be very less externally reflected component because this wall will absorb the light. So direct sunlight will be pretty direct lah, meaning if you have a big window and you're not obstructing it with any internal control or external control, you don't have any curtain, so they will just come into your point of reference, meaning the area where you want the brightness to be. So this three component is the main factors in how much sunlight is coming into your room. So a picture on how the factors are like. So here is your daylight factor component. Okay, so not sure what's this. This is a picture, and they have multiple lighting. So maybe I think I'll delete this away. Okay, so this one is the direct component. And here, and this picture shows the sky component, which is directly from the sun, and then any externally reflected component from the building. Okay, so just remade it here. Okay, so when it comes towards providing enough lighting in the building, it's always a combination between artificial lighting and natural lighting. So to use artificial lighting, it actually costs money to run all year round. So that's why we want to have a combination between natural and artificial. So using natural lighting is always better lah. It actually has a better physiological benefit or effect. Okay, when it comes to a commercial building, we have this sort of called PASLI lah, which is a permanent supplementary artificial lighting of interior. So this is actually just a system of combined daylighting and artificial lighting, where parts of an interior are lit for the whole time by artificial light, which is designed to balance and blend with the daylighting. So it's controlled by a solar activated controller. So depending on how big a room is, then we can make use of this system. So if a room is very, very big, where direct sunlight or the sunlight component or the natural light component is unable to meet or go into the building to reach deep enough into the building, then we will need to supplement it with artificial lighting. So we can call this sort of system a PASLI light system. So this way, during the day, the area close to the window or near the outside light component, we don't have to on it. But then whereas when it goes towards at night, where we require more lighting, meaning during the day or during the night, the total illuminance actually drop, then we will have to on this lighting. So this is to ensure that in the room, the total level of illuminance is up to the level of requirement, which is at a level. So having a room with natural lighting is always good because we don't have to factor in the operation cost. So putting in artificial lighting, then we'll have an additional cost behind it lah. So this is just a system which is called a permanent supplementary artificial lighting of interior lah. Okay, so that's it lah for your topic one. If you have any question, feel free to ask. So we can take a 15-minute break first.